Somewhere in the boundless blackness of space, where the light of stars fades to mere cold sparks in the eternal dark, an object hurtles onward. It has been racing for billions of years, silent, indifferent, deadly, and one day, its path might cross ours. Welcome to a story that doesn't begin in some far-off galaxy, but right here, in our own solar system. The story of an asteroid, whose name every planetary scientist knows today. The story of how a fragile blue dot, called Earth, found itself in the crosshairs of a cosmic projectile, and what we're prepared to do about it. Let's start at the very beginning. Our solar system was born 4.5 billion years ago from a vast cloud of gas and dust. Back then, chaos ruled absolute. Billions of fragments, shards, rocks, and icy boulders careened through the young void, smashing into each other, shattering, merging. Most of them became planets, moons, Saturn's rings, but some stayed wanderers, eternal nomads without a home. We call them asteroids. Today, between the orbits of Mars and Jupiter, lies the so-called main asteroid belt, a vast ring of hundreds of thousands of rocky bodies circling the sun in a slow, stately dance. If you could gather all that material together, you'd get something roughly 20 times smaller than our moon. Sounds modest, but even a single one of those fragments, if it's big enough and fast enough, could wipe an entire continent off the face of the Earth. That's exactly what happened 66 million years ago. An asteroid about 10 kilometers across slammed into what is now Mexico's Yucatan Peninsula. The impact released energy 1 billion times greater than the Hiroshima atomic bomb. Dust and soot blanketed the entire planet. Sunlight vanished for months. Temperatures plummeted. 3/4 of all life on Earth disappeared, including the dinosaurs that had ruled the planet for 160 million years. One rock, one collision, and the entire history of life on Earth was rewritten forever. But that was long ago. Could it happen again? With our telescopes, satellites, and supercomputers, aren't we safe? The scientists' answer gives pause. Yes, we're far more vigilant now, but the threat hasn't gone away. And it has a name: Asteroid Apophis. To anyone who follows astronomy news, that name hits like thunder. Apophis, named after the Egyptian god of chaos and darkness, the serpent that tried to swallow the sun. Coincidence? Or did the astronomers who named it sense something deeper? The object was discovered on June 9, 2004, at Kitt Peak Observatory in Arizona. Right from the first observations, it set off alarm bells. Early orbital calculations showed something unbelievable. The chance of a collision with Earth in 2029 was about 2.5%. In cosmic terms, that's astronomically high. Scientists immediately raised the threat level on the Torino scale, the International Hazard Rating System, to 4 out of 10. For the first time in history, an object had reached that mark. It froze for a moment. Newspapers screamed about the end of days. The internet boiled with fear and speculation. But scientists didn't panic. They calculated, again and again, refining the orbit with fresh observations, cross-checking data from different telescopes. By the end of 2004, the 2029 impact risk was ruled out. A collective sigh of relief. But the story wasn't over. It turned out that in 2029, Apophis would still pass catastrophically close, only 31,000 kilometers away. To put that in perspective, that's roughly 10 times closer than the orbit of our geostationary communications satellites. Closer than many man-made objects fly. So close that, from Earth's surface, you could watch a slowly moving bright point cross the night sky with the naked eye. An asteroid visible without a telescope. Something extraordinarily rare. And that's where the new worry creeps in. During such a close pass, Earth's gravity will tug Apophis just enough to alter its orbit. And if that altered path threads through a particular zone, the so-called keyhole, a gravitational resonance corridor only about 600 meters wide. Then, on the next approach, in 2036, a collision would become inevitable. 600 meters. Picture it. The fate of an entire planet hinging on whether a 300-meter rock slips through a corridor the width of 6 city blocks. This isn't a metaphor. This is real astrophysics. Apophis is about 340 meters across, roughly the length of 3.5 football fields lined up end to end. Its mass is estimated at around 27 billion kilograms. If something like that hit Earth, it wouldn't wipe out all life. That's important to understand, but it could unleash a regional catastrophe on an unprecedented scale, an impact equivalent to roughly 1,100 Hiroshima bombs would instantly vaporize everything within hundreds of kilometers. Shockwaves, tsunamis if it struck the ocean, clouds of dust and smoke, all of it could cripple life on the planet for years. Entire countries could vanish from the map. That's why NASA and the European Space Agency track Apophis with near-obsessive care. NASA's program for studying near-Earth objects is called CNEOS, the Center for Near-Earth Object Studies. There, scientists work around the clock, their computers monitoring tens of thousands of objects across our solar system. Every new telescope image, every radar ping, every orbital refinement gets fed into databases and recalculated. This isn't just science. This is planetary defense. Key tools included the Goldstone radar in California and the Arecibo Radio Observatory in Puerto Rico. While it still stood, radar gives far more precise orbital data than optical telescopes. It measures distances down to meters. In March 2021, when Apophis came within easy observing range again, radar data delivered a stunning result. Scientists confirmed the so-called Yarkovsky effect, a tiny, almost imperceptible, but very real push from solar radiation on a spinning asteroid. Here's how it works. Sunlight heats one side of the asteroid. As it rotates into shadow, that heated surface radiates heat back into space, creating a minuscule thrust, negligible, a few centimeters of orbital shift per year. But over decades, those centimeters add up to kilometers. Because of this effect that, in March 2021, astronomers had to re-evaluate the odds of a 2036 collision. The world held its breath again, but the refined calculations brought relief. Both the 2029 and 2036 risks were definitively ruled out. As of today, Apophis has been officially removed from the risk list through at least 2016. But wait, does that mean everything's fine? Can we sleep easy? Not entirely, because Apophis is just one of thousands of objects astronomers classify as potentially hazardous. According to NASA, more than 2,300 such objects are known today. These are asteroids whose orbits bring them within 7.5 million kilometers of Earth, dangerously close, and that are larger than 140 meters. 140 meters is city-destroying size, and there are thousands of them. Known ones, how many unknown? It's terrifying to guess. That's why, in recent years, we've seen a full-on arms race in planetary defense. Except now, the weapons aren't missiles or bombs. They're telescopes, mathematical models, and spacecraft. In November 2021, NASA launched the DART mission, the first-ever attempt to change the orbit of a celestial body. A half-ton spacecraft slammed into Dimorphos, the small moonlet of the larger asteroid Didymos, at about 6.5 kilometers per second. This wasn't a disaster movie. This was real science, and it worked. On September 26, 2022, DART successfully struck Dimorphos. Ground observations showed the orbital period around Didymos shortened by roughly 32 minutes. 32 minutes sounds trivial, but on cosmic scales of distance and time, it's a monumental proof of concept. We can change an asteroid's fate. We can nudge a rock headed our way. For the first time in Earth's 4 billion-year history, its inhabitants have gained the power to protect their home from a cosmic strike. But let's be honest, there are caveats. DART worked on a small asteroid about 160 meters across. Apophis is twice that size. The dinosaur killer was 30 times larger than Apophis. For truly massive threats, one kinetic impactor isn't enough. We need decades of warning, coordinated missions, technologies still in development, laser tugboats, gravity tractors, nuclear deflection. The last one, using a nuclear explosion not to shatter the asteroid but to gently push it off course, remains theoretically one of the most powerful options, but it demands international agreement, pinpoint calculations, and above all, time. Time is the scarcest resource in planetary defense. Spot an asteroid decades ahead, we have a chance. Years ahead, things get critical. Months ahead, we can only watch. That's why early detection programs are better funded than ever. The new NEO Surveyor Space Telescope, slated for launch in the coming years, currently targeted for around 2027, is expected to find 90% of all potentially hazardous objects larger than 140 meters. That's a revolution in our grasp of celestial threats. Another side to this story that rarely gets mentioned: asteroids aren't just dangers, they're archives. They preserve the raw material from which our solar system formed 4.5 billion years ago. By studying their composition, scientists reconstruct the birth of planets. Japanese probes Hayabusa and Hayabusa 2 brought back samples from Itokawa and Ryugu. In those specks of dust lie answers to where Earth's water came from, what molecules became the first building blocks of life. It's possible we owe our very existence to these cosmic wanderers that, billions of years ago, delivered water and organics to our young world. The universe creates and destroys with perfect impartiality. It feels no pity, harbors no malice. An asteroid streaking through the void isn't an enemy or a monster. It simply is, just as we are. The difference is that we are the only known beings in the universe capable of recognizing the threat and trying to meet it. That's mind-blowing. Pause and think about it for a second. On a small, rocky planet wrapped in a thin veil of atmosphere, creatures of flesh and blood build telescopes, launch spaceships, solve equations, all to shield their tiny home from a billion-year-old cosmic hazard. We are star children who learned to look at the sky not just in wonder, but with understanding. And perhaps that is the most astonishing thing that has happened in this solar system over its long existence. Apophis will swing close to Earth again on April 13th, 2029. It will pass so near that people in Europe, Africa, and Western Asia will see it with the naked eye. A small moving starlet, a reminder that we're not alone in this cosmos and that the universe occasionally tests our resolve. At that moment, dozens of spacecraft will track its every twitch. Scientists worldwide will watch, breath held, as the stony drifter glides past our world. And if it all unfolds as the calculations predict, this won't just be relief. It will be a triumph of the human mind, a triumph of science, patience, and global cooperation. A triumph for the little blue dot that chose to fight for its place in the universe. Space is vast, cold, and utterly indifferent. But we are not. We watch, we calculate, we act. And as long as we do, we have a future. If this video made you look at the night sky a little differently, hit like, drop a comment with what you think about the asteroid threat, and whether humanity is ready to face the cosmos. Subscribe. The universe has plenty more secrets that will flip your view of reality upside down. Stay with us, and see you next time. 1.8 seconds.